we have an integral of x squared minus x plus 6. By the way, this does not factor over x cubed plus 3x, but the bottom factors. Okay, bottom factors means we might be able to write this fraction as a sum of simpler fractions. Okay, sum of simpler fractions. Let's go for that. In this way, x squared minus x plus 6, we can factor x out. So x is squared plus 3, quadratic factor, and x, even if it factors, it does not help. Okay, now we will write this fraction as a sum of two simpler fractions in this way. So let x squared minus x plus 6 over x squared plus 3, x linear factor, so constant on the top, plus x squared plus 3 is the degree 2 factor. This is irreducible. Okay, the degree 2, so we have to have degree 1. So a is used, so bx plus c. This is the generic degree 1 polynomial. Then this integral is in fact integral of these two fractions. So integral of first a over x dx plus integral of bx plus c over x squared plus 3 dx. Okay, we will determine the values of a, b, c later. A outside, we can pull a outside. 1 over x, the entire derivative of 1 over x is natural log of x, plus, okay, we need to separate into two fractions. Okay, bx over x squared plus 3 dx plus c over x squared plus 3 dx. A natural log of x plus b is constant, we can pull outside. Okay, x over x squared plus 3. What is the derivative of x squared plus 3? That's 2x. If we had 2x on the top, then we could use the formula u on the bottom is derivative on the top 1 du, then entire derivative of 1 over u with respect to u is natural log of u. Okay, but we don't have 2, but 2 is a constant, so we can always multiply and divide by 2. Derivative of x squared plus 3 is 2x, so multiply by 2, divide by 2. Okay, when then b outside, b over 2, so we have 2x over x squared plus 3. The top is the derivative of bottom, so the entire derivative is natural log of the bottom, x squared plus 3. And by the way, we don't need absolute value sign here, because the x squared is always positive, plus 3 is always positive, plus c outside, we can pull outside, 1 over x squared plus 3. Okay, derivative of x squared plus 3 is 2x, and we cannot multiply and divide by a variable x, so don't multiply by 2x and divide by 2x, that doesn't help. So we have 1 over x squared plus 3. For that you need to go for a formula. Okay, 1 over x squared plus any constant is square. 3 can be regarded as root 3 square, so 1 over x squared plus a square is coming from 1 over x squared plus 1. We know 1 over x squared plus 1 is tangent inverse tangent, so this will be 1 over a inverse tangent x over a. Okay, you need to memorize this formula, so you will be getting this 1 over x squared plus another number a lot of times. So root 3 we can always regard in this way, so root 3 square, then this matches with this, see outside, 1 over x squared plus a square, That means 1 over a, 1 over root 3 inverse tangent x over a, so x over root 3 plus integrating constant, okay, constant of integration, let's make that k. Okay, this would be the final answer, but we have yet to determine a, b and c. The calculus is over. All we have to do is go back and do the algebra to find the values of a, b and c. Done. So let me bring this to the bottom and find the values of a, b and c. Let me erase this formula. Then this, I want to leave one more step to write down the final answer. So to solve this equation containing fractions, the first thing we need to do is get rid of the bottoms, okay, these denominators. So we multiply both sides by the common denominator of the right side, and the common denominator will be always this, the x and x squared plus 3. So we multiply through by x times x squared, quantity x squared plus 3. Then on the left cancel, we have x squared minus x plus 6, and on the right equals x cancel, so a x squared plus 3 plus x squared plus 3, x squared plus 3 cancel, so bx plus c x. So we get x squared minus x plus 6 on the left and the right, so a x squared plus 3 plus bx plus c x. Okay, let's simplify the right hand side. Just distribute, so ax squared plus 3a, because x squared plus 3 is never 0, so living in this way we can, but it will be difficult to find the values of a, b and c. I would just simplify everything and distribute x plus bx squared plus cx, and combine the like terms, ax squared plus bx squared, a plus bx squared, and xcx plus 3a. Okay, and the left hand side is x squared minus x plus c. Unlike last questions, we don't have linear factors. Okay, this is a quadratic factor, so plugging in x equals 1, 2, 0, that does not help. Okay, now we are saying this left hand side is equal to right hand side. That means the coefficient of x squared, a plus b, the coefficient of x is 1, this should be equal, so a plus b must be equal to 1. A plus b equals 1. Cx negative 1x, so c should be negative 1. 3a equals 6. Okay, now we solve this system of linear equations for a, b and c. C is already solved, that's good news. And 3a equals 6, we can find a from here, that implies 3a equals 6, so a equals 6 divided by 3, 2. A is done, c is also done. Now b, just from here, a is 2, so 2 plus b equals 1, so b equals 1 minus 2, negative 1. So a is 2, b is negative 1, and c is negative 1, so 2, negative 1, negative 1. Go back, plug those in. So a is 2, so natural log of x, plus b is negative 1, so I'm going to put negative 1/2, natural log of, we don't need absolute value because this is always positive, and c is also negative 1, so negative 1 over root 3. This is okay, you don't have to rationalize. Tangent inverse x over root 3 plus k. Final.